And this is Maldonado here. So we're going to go ahead and start section 10.1. Right, we're skipping chapter 9 for now because it deals a lot with transformations, dilations, and stuff. But we need to kind of cover circles, so we're going to cover circles and then we'll go back to chapter 9. Right, so the first section is called using properties of tangents. Okay, now tangents kind of has a secondary meaning. We know about tangent from the trig ratios, but it also is something that's quite used often when we work with circles. Okay, so now what I want you guys to do is we have this box here with the vocabulary, all these definitions: circle, radius, chord, diameter, secant, tangent. Make sure you copy those down into your notebooks, and then the two theorems, make sure they're in your proof notebooks. Okay, so pause the video if you need to get all that down, and then we'll continue on from there. Okay, so everyone pretty much knows what a circle looks like, right? But everyone kind of thinks of a circle as a shape. But in reality, circle is the set of all points in a plane that are equidistant from a given point called the center of the circle. So basically the idea, okay, is you have a center point. Okay, that might be a little, you have to shrink down the size of it. Okay, so you have a center of a circle, right? So they all have, all the points on the circle, whatever it is, have to kind of be equidistant from it. Okay, so there is our circle. All right, now the idea of it being equidistant is that the length from the center to the edge of the circle is going to be the same throughout, right? And we know that to be the radius. The radius is this segment that's going to be kind of drawn throughout the circle from the center point, and it's equidistant throughout, right? So that's what they're referencing. They're referencing all these points, okay, all these points on this part of the endpoint here, okay? These are all the points on the circle. So there's technically an infinite number of points on a particular circle, okay? Okay, let's talk about the three segments that can three segments or lines that can be drawn with a circle. Okay, so let's erase this one here. All right, so here's our circle. Okay, there's our center point. We have what is called a chord. Okay, now chord is the most simplified version of the segment. Its basic definition is a segment whose endpoints are on a circle. Okay, so it has to be a segment, and the endpoints need to be on a circle. Okay, so there's like different ways we can kind of draw this. We can draw this, here's an endpoint, here's an endpoint, that's a chord. Here's an endpoint, here's an endpoint, that's also a chord. Here's an endpoint, here's an endpoint, that's a chord. So there's so many different ways of actually drawing a chord. Now I do want you guys to focus on the middle one here. Okay, can you tell me what else is on the center segment here? Okay, now if you're saying that the center is also on that position, then you're correct, right? So a diameter is a special type of chord. A diameter is the chord that also collects the center point, okay? Here in the other two, it does not collect the center point, so we can only describe them as chords, whereas the one that collects the center point, we actually have a specific name for that. We call that the diameter. And we all know from past experience, the diameter is pretty much the sum of two radii, so it's going to be 2 times the length of the radius. All right. And now let's talk about lines that intersect the circle. Okay, so let's erase what we have here. All right, so here's our circle. Excuse me. A secant is a line that intersects a circle in 2 points. Okay, so your secant is going to be any line that's going to go through the circle. Again, the line is infinite. Okay, so the secant goes through the entire line. So let's say that this is point A and this is point B. When you're talking about the secant line, you're talking about the entire line AB. However, the secant line contains the chord of the segment AB. Okay, so the secant line contains the chord, but since the secant is a line and it goes infinitely in both directions, then that we consider the secant. But technically, both geometric figures are in this figure here, because segment AB is a chord, while line AB is a secant. Okay, and then the other one is a tangent line, and that's going to be the main focus of this section, is this tangent line. Okay, so the tangent line is only going to intersect the circle at one point. Okay, that's what we call the tangent line right there. It's going to just touch that one point on the circle, and then that's all, nothing else. Okay, now we call this position here the point of tangency. Okay, that's the point at which the circle is intersecting the tangent line. Okay, so that's all the definitions for the main vocabulary that we're going to kind of be using for the most part of the chapter. Obviously, we'll come across more vocabulary once we start getting into arcs and other things like that. All right, so those are all the definitions and give you kind of visualization of what's actually going on. Okay, then let's look at the two theorems. Okay, so let's erase what we have here. All right, so the first theorem is, in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. Okay? All right, so here's the idea. The idea with the if and only if is stating that you have a circle. Here's your center. Let's draw a tangent line. Here's your tangent line. It's only intersecting at this position. What it's saying is no matter how it's drawn, where this tangent line is to a circle, right? The tangent is going to be perpendicular, okay, to the radius of the circle. Okay, it's going to be perpendicular to the radius of the circle. All right, now that's very important for us because then we can start to draw some right triangles if we needed to, right? So perpendicular lines are always powerful, especially when we're able to use trigonometry. So you know, that's an idea that's going to be here, and we get to use that quite often. Okay, and then the second theorem, okay, and I'll draw it at the top right here. Okay, so we have our circle. All right, tangent segments from a common external point are congruent. All right, so the idea is, let's say you have a point here, okay, and you have a tangent line that goes this way and a tangent line that goes this way, okay? Then, or tangent segments, so let's make this a segment itself. Then what it's saying is that this segment's going to be congruent to this segment. All right, so that's the second theorem. Okay, so the first theorem is the idea that all tangents are going to be perpendicular to the radius, and the second theorem is that those two are congruent. Now, if you need to see a quick proof on why that is, right? So since this line is tangent, I know that this radius is perpendicular, and this one as well, okay? And then if we quickly draw an auxiliary line here, notice that you're going to have two right triangles, and these two right triangles are going to be congruent by the HL theorem, okay? Because all radii from a circle are going to be congruent to themselves, and this is reflexive, and that's the hypotenuse, that's the leg, so we have HL. Okay, and HL here gives us that theorem. All right, so again, what we need to know is that any point on the outside of a circle, if there's two tangents drawn from them, those two tangents are going to be congruent in length. All right. Okay, so that is a lot of the information that is from this section. So now all we have really to do is just to do some examples just to get you guys used to applying some of the theorems and definitions that we just learned. Okay, so let's get all these drawings out the way. Let's scroll down a little bit. right? Again, if you have any questions, just a quick message or comment to me. I'll probably get that to you as best as I can. All right, so here's an example, okay? It's just identifying some special segments and lines. All right, so let's look at A. It says tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle P. All right, so the notation for a circle is always going to be the circle with a dot and the capital letter for the center of the circle. So if you look at the circle, the center is P, so that is the correct notation to use for a circle. All right, so RT. All right, so RT, all right, it's definitely going to be a chord, but this chord has the center on it, so A is going to be the diameter. Okay, let's look at B. B is ray WT. Let's look at ray WT. If you look at ray WT, okay, it's a ray, so it's a part of a line, but that ray is tangent to the circle at point T. So this is what we call a tangent. All right, C, PT, is the radius. And D, line RQ. So notice line RQ is intersecting the circle twice, so that's going to be a secant line. Okay, so those are the 4 responses. Okay, again, straightforward, just identifying what the segments and the lines are, just using the proper definitions. Okay, so now I want you guys to pause the video, try 1 and 2, and then in a matter of seconds, I'm going to start 1 and 2 so we can do it. All right, so looking at the diagram in the example that we have above, what word best describes QR? Okay, so segment QR, again, pay attention to the notation. Segment QR is what we call a chord. Okay, and the second part to the question is what is segment PR? Segment PR is a radius. Okay, because it's a point that goes from the center to any point on the circle. Okay, and then part 2 says using the diagram in example 1, name a tangent. All right, so you just have to name a tangent here. So the tangent is going to be line XW. Okay, one that we haven't named before. XW would be considered a tangent. All right, so that works out. All right, so let's go on to the second page here. All right, so here we're going to be finding the lengths of circles. Okay, so find the lengths in circles in a coordinate plane. All right, so this is what we have here. So we need to find the lengths or the diameter of P. Okay, so now that you guys can quickly calculate, it looks like it's a length of 8. So the diameter is going to be 8. Let's look at the diameter of Q. So if the center is at a unit, a y value of 8, and the distance from 0 to 8 is 8 units, then the diameter is going to be 2 times the radius. So that's going to be 16. All right, let's look at the radius of P. All right, so we're looking at the radius of P, not the diameter of P. So the radius of P is going to be correct 4 units. All right, and then let's look at D. What is the radius of Q? Okay, so the radius of Q, again, the Q is the center point of the larger circle. So the radius is going to be 2 units of 4, which is 8. All right, so there you go. You have the diameter of P, which is 8, the radius of P, 4. The diameter of Q is 16, the radius of Q is 8. All right, so just knowing that property of radius and diameter, I'm sure you guys mastered that already coming from previous years, but there you go. Okay, here, tell how many common tangents the circles have and draw them. Okay, so a common tangent is different ways that we can draw a tangent where both circles will have a tangent drawn, okay? Now, the only thing is that, remember, the tangent cannot go on the interior portion of the circle. It has to strictly be on the exterior portion. So if you look here, I can draw a common tangent right there. Okay, let me actually try to, oh, sorry. Let's go back. Undo. Let's try to draw that a little bit better. Okay, so that's one common tangent. And here is another common tangent. Right, so this circle has two common tangents and they're both on the exterior portion of the circles. Okay, now this next one, we're gonna have quite a bit more, right? So you still have the two that are out here. That's one common tangent. Here's another common tangent. But then you also have the ones that cross in the middle here. So that's another one, tangent to both circles, and another one, tangent to both circles. Okay, so now if you look here, they were only considered the exterior tangents. But here we have a combination of exterior and interior tangents. The ones that are interior are the ones that cross. They pretty much cross the center point of the circle, right? So if we drew a line there, they're crossing the interior portion of the circles. So we call those interior tangents, okay? Now C is a little bit tricky because you have to figure out a tangent, but notice that both of them have the same point on the circle here. So technically, if we drew a line like this, it would be tangent to both circles at the same time. So they share a common tangent, which is there, okay? All right. Let's go down. I'm sure we have some examples here ready for you for the other ones. Okay, so here we go. Okay, it says to verify that verify tangent to a circle. Okay, so they're just telling you that they think it's a tangent. You need to verify that. How would you verify that? Okay, so if segment AB is a radius of A, show that BC is a tangent to A. Okay, so there's two kind of ways to prove to show that or prove that here. We just need to make sure that segment AB is perpendicular to segment CD. Okay, if we can show that, then it is a tangent. Okay, so that's all we need to show. All right, so really quickly, if you look at the small triangle left, we have a 6, 8, 10 triangle, so we have 10 squared. We're going to check to see if that is the hypotenuse for a 6 squared and 8 squared side. Okay, and that gives me 100 is equal to 36 plus 64. All right, and that checks out, right? That is, that's good. 100 equals 100, so we know it's a right triangle, so therefore we verified that. Okay, so that's what they wanted you to do for this particular example. Again, understanding that all tangents are perpendicular to the radius, right? So you could have also used the 8, 15, 17 triangle. So if you wanted to use that one, you would have gotten the same result. Okay, so let's continue down. All right, so here we have used the diagram in example 2 to find the diameter and radius of circles R and S. Tell how many common tangents the circles have and draw them. And using the diagram in example 4 is segment BD tangent to A. Okay, so again, pause the video here, copy these questions down. I'll scroll up to the top so you guys can see the image from example 2. Okay, because example 4 is already here on this page. Okay, so really quickly, we're looking at circle R, okay? All right, so that looks like it's a quarter of the way up from 4, so that's going to be a unit of 5. So that means the radius for 5, or the radius for circle R is 5. And so that means the diameter should be 10. And there's 10. Okay, and then looking at circle S, the radius is 3, and the diameter is 6. Okay, because it's a quarter of the way down from 4, so that's going to be a unit of 3, so that's the radius, and then double that, we'll get the diameter. All right, so let's go up. Okay, number 4, tell how many common tangents the circles have and draw them. Okay, so number 4 is actually going to have 3 common tangents. Okay, so let me try to draw these. Zoom in a little bit maybe. That's 1, that's 2, that's 3. Okay, so 3 common tangents. All right, here This one has 0 common tangents. All right, there's no way to draw a point outside of the smaller circle without drawing one on the inside of the larger circle. Okay, and then here we have 1. Okay, so we have 3, 1, 0, 1 as our solutions. Okay, and then this is using the diagram. Is segment BD tangent to A. All right, so here they actually want us to use specifically BD. So 17 squared, is that equal to 8 squared plus 15 squared? All right, so that's what we're trying to figure out. So 17 to the second power is 289. Is that equal to 64 plus 225? And that checks out. All right, so we are good. So that's it. Okay, so that's the section. Hopefully this video helps. Again, if you have any questions, any lingering questions, please ask me. All right, so again, you'll have a homework assignment, so just get that done. And then we'll move on to the next section. All right, okay, hope this video helped you guys. Talk to you soon.